Hi everyone, Hussein is here from HDM Electrical. Today we're going to talk about switchboard upgrading, a recent project which I've done for a Cherrybrook customer. As much as I want to record it live while I'm doing the job, always something happens that cannot be done, including the wind and the bad noise or surrounding voices, which does not make it quite clear. So what I've done today is that I took a picture of different steps of the jobs and then I record my voice on it with all the details that you need to know, and it's going to be beneficial hopefully for you and for future project. So let's start. As you see in this customer, she has ceramic fuses. It's about 30 years old house. And she has 3-phase. As you see, the switch has, the size of the switch is 3-phase. Everything in this board, as you see, is ceramic fuses and are single phase, except the air condition, which has been pretty much 10 years ago added to the property, and that's why this block looks pretty new compared to the rest of the board. The other thing that using more than one phase is the hot water. As you see, this here we have main switch labeled, and again here we have main switch. That's for the normal supply, which shut down the 3-phase supply to the property. This one is for hot water only because, as it says in here, it's off peak. So when you are dealing with the off-peak meter and you are using off-peak for your hot water, which is mostly is the case, you need to make sure you turn it off before working on the hot water, and just turning this one off doesn't do anything for hot water as long as the hot water is connected to the off-peak. So let's start on that one. We have to remove everything on this board, obviously. Everything has to be removed, including the wires, switchboard, the switches, the fuses, and even the new one which has been added, including the base of the fuse. So in order to do that, we have to notify the customer that the power is going to be off, so they have enough time to shut down everything that they have, including sensitive stuff like computer, or they have to save the file or whatever. So notify the customer, turn everything off. Initially we turn these switches off, then we move on, as I just wanted to show you in this one, that is a 55 amp 3-phase switches. Then we have, as it shows in this picture, when we turn the switches, the existing switches off on the board, we have to remove the service fuses. Keep that in mind, because we want to get rid of this switch which was here, this one I'm talking about. So in order to remove that one, I have to cut the power which supplied to this switch, and that can happen only by removing the service fuses in this picture. So first I turn those one off, then I remove the service fuse off. Then again, before I do anything, I test to make sure there is no wire behind the panel which is live. So when I make sure everything is okay to proceed, I start removing the switches one by one, as I've done it in this picture. I just left a couple of them just for example, so you can see what's going on. Every single switch or fuses that I'm removing, I have to make sure the rating of the fuse which used to be connected, also the labeling which says what appliances or what part of a house that one is controlling, and that's called labeling the cable. As you see, the cable is hanging here, there's a tape around it. I made a mark by the marker or something like that to make sure that one used to be connected to associated number 6 or number 5 or whatever circuit number, and what was the rating on it. Okay, so this part is pretty important, because if you mess it, yes, you can put the circuit back on later on, but it may come up with lots of problems, including not knowing which part of a house is controlled by that one, which is another problem. Also, you may judge the rating on proper fuse based on the thickness of the cable, which may not be 100% accurate, because in the old houses, sometimes halfway of the wiring, the size of the cable is changing. So it may shows in here, for example, a cable that can tolerate 20 amp, but halfway towards the appliances, they change the cable to something smaller. So always stick to the rating and make a note of the rating of the fuse which you have removed, because later on when you replace it with whatever protected devices like a fuses or RCDs, like a circuit breaker or RCDs, you have to make sure that's the same rating as it used to be. Okay, when everything is removed and clear, the next step is find an enclosure which is gonna fit in this size. For that, we need to do the measuring and find the proper enclosure. Some people are the fan of, you know, using more than one enclosure when the space is quite tight like this one. I'm not the one. I prefer to be all of them in one because it looks much more professional and nice and tidy. So it was quite narrow space. I found something that actually fitting in that space. In this picture, as you see, which I told you before, I bundle the cables which used to be connected to this associated switches or something like that. I made a marking which, as you see in here, I don't know if it's visible. Yes, it is. Actually, as you see, I have made a marking which represents the circuit number. For example, if I have 6 or 7 marking on it, that means it used to be connected to the circuit number 6 or 7 or whatever. If it's more than one circuit connected to one fuse, I combine them and wrap the tape around it. So this step is time consuming, obviously, but it has to be done perfectly, because that makes the job much easier and less hassle when you want to connect everything back on. Keep that in mind when it comes to this phase, when it comes to the 3-phase. As long as all the loads are actually single phase, you don't need to be worried about the phase sequence. But if you have a 3-phase or 2-phase appliances connected to the main switch, just like the hot water or the air condition, the phase sequence is very, very important, because if you mess up with that one, it may blow the machine, it may damage the machine, it may start working in the reverse, and it causes lots of other problems. So if you have 3-phase or 2-phase load or appliances in one house, whether it's a residential or is a commercial property, make sure you also note the phase sequence as it was before you dismantle the board and, you know, disconnecting everything. Okay, so what's next? Okay, so after that step, next one. Okay, next. So in this one, as you see, I start mounting the enclosure. Quite pleasantly, it just fit in the same space as I was hoping to. So when you mount the enclosure, you have to make sure that it's gonna line up properly, and also it doesn't swing to the left and right, or, you know, it's not completely horizontal. When you mount that one, the next step is starting to put the circuit breakers, switches, or the RCDs one by one. Usually, as a rule of thumb, that's what I do, is that I put the main switch on the left, and then all the other switches, circuit breakers, or RCDs are gonna line up based on the rating from top to the bottom. That means the one on the right has a higher rating, the one goes towards the the one on the left has a higher rating, and the one goes towards the right is actually less rating. Okay, so if I started, this one is 63, actually that one is a 50 amp, because remember the one I removed was 55 amp switches, so I replaced it with the 50 amp circuit breaker 3-phase. And then the next one, as you see in this picture, is RCD or safety switches, which is 20 amp. The next one is again 20 amp. The next one is 16, 16, 10, 10, and 10. So the rating goes from left to right, from high to low. Okay, so when you've done that, the next one is going to be air condition on this panel specifically, because remember I want to use the same circuit breaker. I'm not going to install the RCD for the air condition for a very obvious reason, because the unit is old and there is a big chance of tripping the circuit. If I connect the RCD, there is a big chance that's going to trip frequently, so I'm not going to install RCD for that one. And the next one, as you see in this picture, is 2 circuit breaker, brand new, for a hot water. One of them, as it used to be, is going to control the bottom element, which is connected to the off peak, and the one on the left is connected to the normal supply, which is controlling the boost element, or the top one. Okay, so we do that one, we start connecting the wires. What I have done is that the supply is from the top for the main switch, and the bottom is connected to the load. In order to make it nice and tidy, for the rest of the circuits, the load is connected to the top and the supply is connected to the bottom. Keep that in mind, unless the circuit breaker or the safety switches is specified that there has to be one side just for the load and the other one for the supply, you are not obligated to follow that. That means some manufacturers, they are not a lot, but some manufacturers say that you have to connect the supply to the top and the load has to be connected to the bottom, but not everyone. If that's the case, you have to follow the rules, because in that design they have considered that, and if you not follow the rules, follow their specification, it may not work as it's supposed to work. Okay, so but for example, this brand specifically, which I'm using, or other famous brands, there is no difference whether it's connected to the bottom or it's connected to the top, it does the same job. Okay, so from the bottom connected to the bottom of this one, and so on. So when it comes, the next point that you have to consider all the time is that when it comes to the 3-phase supply for the residential, as we have in this one, we have to make sure that you do the load distribution, equal load distribution properly. That means you have to consider and calculate the amount of the load that you have in terms of number of the circuits that you have, whatever is controlling this and that, and distribute the loads between the 3 phases equally. You cannot just overload one phase and leave the other one, on the light load or not connected to nothing, because that's against the rule. It's not going to do anything positive for you. Obviously, it's going to cause it somehow cause more tripping, which you may not know what's the problem. It actually have a bad effect on the grid, because one phase is going to be overloaded and the other one not, which may trip the fuse in the transformer in the grid supply, and it's going to create a disaster pretty much when it comes to the supply. If you and a couple of your neighbors do that, there is a big chance that the transformer on the local transformer start tripping. Not only that, which is going to cause the blackout, also you may experience tripping locally. That means you think you are running everything normal, nothing, big load or something, but all of a sudden you see the circuit, the main switch is tripping. You may assume that it's going to be something false in the circuit, but it's not. It's because of the bad load distribution, which was not equally distributed between the phases and caused one of them get overloaded, and that's why the switch has tripped. So load distribution is the key in this stage, and it has to be done properly, and you cannot just go connecting whatever you want and assume everything is going to work properly. Okay, so again, it's always good to emphasize again and again and again that when it comes to the three-phase loading, phase sequence is very important, because if you mess up, for example, when it comes to the aircon, you may experiencing absolutely different scenarios when you are not supposed to. For example, if you connect the three-phase AC in the wrong sequence that is meant to, your compressor is going to start working the other way around. So when you are controlling, for example, on the heat situation, like for a winter mode, it actually start giving you the cold air, just like a summer mode, and that's just a lucky result, because if that happens and the customer or you do not realize that one, and the customer just running it for a couple of hours, it may cause the compressor to freeze, and obviously when it freezes, the whole compressor is gone. They have to repair it, they have to replace the part, and it's going to be costly, and it's going to be all your fault. Okay, when it comes to the pumps, that's the same. When the phase sequence is wrong, the pump is going to start rotating the other way around in the reverse option, which is not meant to. That means it's going to increase the pressure, it's going to get overload, the pump's going to burn, it's going to blast a couple of valves and this sort of stuff. So it's always important to make sure the phase sequence is right if you do not want to cause trouble, financial trouble for yourself, for your reputation, and for the customer. Okay, so when this stage is done, keep that in mind. I have done the marking, as you see, the number of actually every circuit as it used to be, 1 2 3 4 5 6 7, and then this one is 8 and 9, and this one is supposed to be 10. But what you need to consider is that this labeling is also help you to connect the associated natural cable to the natural link, which is behind the board. So not only you have to mark the natural link number to every circuit, which I've done in here, you also have to make sure that you make everything nice and tidy, so next electrician is going to work, if they want to disconnect the wire, they can see which cable is connected for which circuit to which neutral link. So if they want to disconnect or terminate the number 1 neutral, they know they can go to the neutral link on the back of this board, and they can unscrew and remove the cable which is connected to number 1 slot. Okay, so it has to be done properly. The next step is, as you see in here, which is more clear. So N1, N2, N3, N4, N5, N6, N7. That means neutral link number for this circuit, which is circuit number 1, is connected to a slot number 1 on neutral link, which is behind this board. That's a screw holding the neutral link on the board. So if you want to know which slot is connected to the neutral for this circuit, is N5. So you just go in the back, find the number 5, unscrew it and remove it. Okay, so that's what it is. Okay, after this step, what needs to be done is putting the cover back on, put the fuses, service fuses back on one by one. Make sure when you do that, let's go back on this one. As you see, the main switch is off. These ones are on for no reason. So as long as this one off, none of them is going to be energized, so it doesn't really matter it's on or off. But before you put the service fuses back on, you have to make sure this one, this one, this one, and all of them are off. So you make all of them off, then you put the service fuses back, then you start turning each of them one by one as it goes. So after you install the service fuses, you turn the main switch on, then you start the first one on, second one, third one, fourth one, like this. Okay, at this stage we leave the panel as it is, we go inside the house and we start checking to see everything is energized and is working fine. Feel free to ask the customer that to check the entire house in terms of the lighting, power points, appliances, cooktop, hot water, everything. So when they are happy and you are happy with the result, the next step is to start do the labeling. Labeling is an important part. Remember, you may know what you have done, but the next person or the owner doesn't know which circuit is going to control what appliances or what load. So they have to know what is what. So the next time the electrician comes or they want to do something, they know which circuit they have to turn off in order to work on that one. So if they want to, for example, disconnect and replace the hot water, they know which one they have to remove it, or which one they have to lock it, turn it off and lock it. Or if they want to work on the air condition, they know which one they have to turn it off before they start opening the panels on the air condition. Or if they want to work on the stove or something like that. So they don't need to turn the entire power off just because the electrician has missed to put the labeling, or they don't want to put themselves in danger because they don't want to do something risky. So if you do the proper job, as I said again, and you have done the proper labeling on the cable before removing the fuses, now it's going to be very easy for you to label them back again. So okay, as you see, it's pretty straightforward. Main switch, and then wherever you have safety switch or RCD, and RCD stands for residual current devices. So you need to label them as a green, means it's going to be protected circuit. And whenever you haven't used it, you just put the red label and you make sure you label it properly that says this is not protected by residual current devices. So for hot water, I haven't done that one because I know why, and you are not, if it's an old system, you better not to do that because there's a big chance of tripping a lot. Air conditioning is the same. What else? As you see, the labeling is done. So protected light, protected light, protected power, hot plate or wall oven. Okay. Then we do the labeling and we explain that one to the customer, obviously. So they know what is what, because they need this one in case something goes wrong or in case of the emergency. They need to know where they have to come back and what they have to do in order to isolate the situation. Make sure you mark the main earth location, because usually they write it on the board, but since these enclosures cover the marking on the board, you have to make sure that whatever is essential is being written on the enclosure. It's good actually to leave your contact details in case the customer need to get back to if something goes wrong. Not after installation necessarily, but even after a while, if something goes wrong in their house and they need someone to be contacted, or because you're going to be the last person who have done the job on that board and you have some ideas which can help them figure it out if something goes wrong. Okay, next one is cleaning the wires at the back. Remember I told you about this neutral link which is connected in here? That's what I said when it's come to the marking of the slots, because when you remove the cover, you will see the numbering on the main bar says 1, 2, 3, 4, 5, which shows the number of the neutral wire, which if you have done the proper labeling in the front, the next person is gonna work is quickly can figure it out. You know what? That's number one. I have to disconnect, unscrew that one and remove it if I wanna isolate it. Make sure the job is nice and clean as much as possible. Just don't leave the messy cable on the back. Use the cable tie, try to clean it up, try to bundle them so it's gonna be easy for you or the next person to close the board or open it and not too much mess around, so they can actually chase the wires if they want to. So if you do the good job, I'm not saying this one is perfect, but that was the old wiring and I couldn't do much about it, but it was much worse before I took it off. So try to do your best and get the pride of providing the good job for what you have done. And that's the final result. So everything get back onto what it was. We put the board back in, put the bolt again, make sure nothing is missing. It's gonna be a good idea if you again come back inside, check everything, double check with the customer to make sure everything is working fine, and you can explain again to the customer, make sure they have proper understanding of what's going on, what's the labeling, what they have to do in case of the emergency. And that's gonna be it. Hopefully this information is clear enough for you to understand and have a better understanding of what needs to be done as a switchboard upgrading. It's worth mentioning that just because it looks easy doesn't mean that's a DIY job. Never ever try to do a DIY job when it comes to the switchboard, because not only you put your entire house at risk of the fire, you also put your beloved one in the risk of electrocution, and there is a big chance that you electrocute yourself. And keep that in mind. When there is nothing in here connected as a protective devices, which is happening, as I said, during the process of upgrading, and also the fuses are removed, that means you are connected directly to the grid. So if you get electrocuted, nothing gonna stop you and save your life. So never ever think about doing this and save some money, because you may end up costing your life and a lot more to your property, and it's gonna be a heavy fine if someone reports you doing that. Although I've experienced one person has done it, and lucky the new owner picked that up and it cost him something, but obviously if he wasn't fixed that one, his son was supposed to be electrocuted because the guy, the previous owner, has done something completely irresponsible and done some upgrading by himself and put the entire board energized, which I tell you later in another video or something. Hopefully it has been helped, and feel free to ask me any question if you have any. And make sure, if your house is not up to date when it comes to the protective devices, it's highly recommended to do that, because remember, fuses, ceramic fuses or whatever old protective devices that you have at house does not provide you any kind of a protection when it comes to the electrocution. It may help the wiring not to burn, but when it comes to electrocution, it doesn't provide you any kind of protection whatsoever. So switchboard upgrading, it's pretty recommended, it's pretty necessary and essential, and do not think saving money on that one and skip the rules and amendment as per Australian standards, which is somehow compulsory to be followed as per new regulation, is a smart act. It's not smart to ignore it and think you are saving money, because if God forbid something happened to you, then you're gonna end up paying much more to fix something and much more regret. Have a great day.